Here we're asked for what values of a does the graph f of x equals x plus a over x squared plus 4x plus 3 have a hole. Then to explain, and for each of the a values state domain and range of f of x using interval notation. So in this case here, first of all, I'm going to go ahead and factor this to see where our holes are going to be at, because I'm looking for two numbers that multiply to 3 that add to 4, which will give me x plus 3 times x plus 1. And so there's actually two values of a that would give us a hole. We could say that a is equal to 3 because that would give us x plus 3 over x plus 3 times x plus 1. And these would cancel out, so we'd actually have a hole at negative 3 and then a vertical asymptote at x equals negative 1. And then there's another situation here where we have x or a is equal to 1, which would give us x plus 1 over x plus 3 times x plus 1. And the x plus 1s would cancel out, so I'd have a hole at negative 1 and then a vertical asymptote at negative 3. So basically in this case here, if we're asked for the domain and the range of these, the domain is actually going to be the same, because in both of these situations, the x values cannot be negative 3 or negative 1. So for the domain for both of them, I'll do here in green really quick. Domain in interval notation is negative infinity to negative 3. I'm going to probably run out of room here. Negative 3 to negative 1. And then I'm bringing this down here because I ran out of room, going from negative 1 to positive infinity. So that's the domain for both. The range is a little bit tougher because in the range, what I need to do is I need to figure out, well, I know my horizontal asymptote because the degree of the numerator is less than the degree of the denominator. So I have a horizontal asymptote for both at y equals 0. But the hole, that's what throws us off and adds another spot where y can't be a certain number. So what that means is that we're actually going to look at wherever the hole is. In this case, it is x equals negative 3. And we're going to plug that into the equation to find out what our y value is not going to be also. So in this case here, what I'm going to do is I'm going to plug it in. Well, let me simplify this really quick because this ends up being 1 over x plus 1. So basically I can just plug in negative 3 into here, which gives me 1 over negative 3 plus 1, which is end up being negative 1/2. So my range, although a little bit weirder here, is going to be negative infinity to negative 1/2, negative 1/2 to 0, and 0 to infinity. So that's for the left side here. Now, for the right side, it's a little bit different because our hole's in a different spot on the graph. Now, in this case, also our graph simplifies to 1 over x plus 3, and my hole is at negative 1. So I'm going to plug that in, 1 over negative 1 plus 3, which gives me 1 over 2. So in this case, my y value is not going to be 1/2. So I have a range here of negative infinity all the way to 0. And again, it's 0 because we still have a horizontal asymptote at y equals 0. Then from 0 to 1/2, then 1/2 to positive infinity. And again, just to kind of like show you what this means, in this graph here, it's going to look something like this. But because we have a hole when x is equal negative 1, we have a hole right here, meaning the y value at this point is also not there, right? So the y value does not become wherever that is. And so we have to find what that y value is, and what we did, or how we did that, is we plugged that into the x value. So I did it here in red, and I also did it here in pink. So that gave us two spots in the range that y could not be equal to, the horizontal asymptote and whatever the y value is for the hole.